In this last video on basic antiderivatives, we want to look at antiderivatives of exponential functions. If you recall from differentiation, we learned that the derivative of e to the x was itself. So the antiderivative of e to the x is itself plus perhaps some constant. And this just naturally follows from what we know about the derivative of e to the x. Derivatives of exponentials in a base other than e, like perhaps 4 to the x, we learned the derivative here is the natural log of the base times the exponential itself. So in finding these derivatives, we multiply by the natural log of the base. So to find the antiderivatives, we're going to divide by the natural log of the base. So the antiderivatives here is 1 over the natural log of 5 times the exponential itself plus c. Okay. And just to put a cap on the videos so far, let's just look at one review problem. Say some sort of goofy function like this. Now we have a number of terms that are either combined through addition or subtraction. So when we find the antiderivative, we're simply going to take the antiderivative of each term and add or subtract as appropriate and tack on a constant c at the end. So for this first term, right, straightforward power rule, we want to add 1 to the power, so that's x to the 5th. Divide the coefficient by the new power. So the antiderivative of this term is going to be 3/5 x to the 5th. To find the antiderivatives of this guy involving a root, right? Recall we want to think about the fractional power, in this case 4/3. So here I want to add 1 to the power, so that's x to the 7/3. Coefficient here is a -1, so I want to divide -1 by 7/3. So that's just a -3/7. Antiderivative of 1 over x. Recall this is x to the -1. We can't use any sort of reverse power rule here. The derivative here, the antiderivative of 1 over x is the natural log of the absolute value. And the antiderivative of this guy, which we just covered, is going to be 1 over the natural log of the base times the exponential itself. All that remains is a plus c to represent any constant.